Today we're going to work on finding the volume of triangular prisms. An example of a triangular prism is shown right here. A Toblerone bar is a triangular prism. A triangular prism is often confused with a pyramid. A prism has two bases that are equal. A pyramid has only one. So we're going to talk a little bit today about what makes something a triangular prism and how to find its volume. If you notice on your reference sheet, there is no formula given there for a volume of a triangular prism. What we're going to do today is we're going to use this formula right here, capital BH, or base area times height, to find the volume of a triangular prism. So when I look at this shape, the first thing we need to consider here is what shape is the base. If we're going to use this formula, volume equals capital BH, where capital B is the base area, I need to calculate the base area, which means I need to know what the base is. The base of a three-dimensional shape is the shape that goes throughout in the exact same way through a three-dimensional shape. So this rectangle here, a lot of people will look at and say, oh, that's the base. But if I repeat that rectangle over and over and over in the same way, I'm not going to create a triangular prism. I would create a rectangular prism. The base on this shape is this triangle. Now, this triangle and the triangle at the top are equivalent. You could pick either of these. But what matters is you pick the triangle for the base. So if that's the base of this shape, there are matching bases, so I know that works. The first thing I know I need to do is to find the area of it. So if capital B is the base area, and I know the base shape is a triangle, I'm going to take base times height divided by 2. That's the formula for area of a triangle. I know that from my reference sheet. So looking at my triangle here, I know that a right angle connects the base and the height of a triangle, so I'm going to use these two numbers here. 4 times 3 divided by 2 gives me 6 feet square. That's the base area. 6 feet square. That's why it's feet square, because it is area. Now if I go back to my formula says volume equals base area times height. So now I need to ask myself, along which side of this three-dimensional shape would I stretch the triangle or stack the triangle to make it three-dimensional? I'm not going to stack it along the 3 or the 4. I'm going to stack it along this measurement, which is the height then of the shape. The height doesn't always have to mean up in the air. It means the other dimension of your shape besides your base. So basically I'm going to take my base area, which I know now is 6, and I'm going to stack it to fill up this height. So my base area was 6, so I'm going to substitute that in. My height was 5. 6 times 5 gives me a volume of 30 feet cubed. It's volume now, that's why it's cubed. Base area was squared. Now, this isn't a particularly complicated concept other than when you get to shapes that it's hard to identify the base in. Sometimes these shapes get messy because a lot of people want to think of this bottom rectangle here as the base. I would encourage you to think about the fact that a base is the same shape that can go throughout the entire three-dimensional object. If I take this rectangle and I stack it, I will not make a triangular prism. So that cannot be the base. I need to ask myself, what shape can I use that can be stacked to create this? And the answer to that is this shape right here. Sorry. This triangle at the bottom. So if I know that's my base, again, volume is capital BH, base area times height. So I need to find the base area, which is the measurements of base and height divided by 2. These are different, okay, values. This refers just to the triangle, not to the three-dimensional object. So when I look at this triangle, I need to decide what the base and height are. I know the right angle connects the base and the height, so I'm looking at this value and at this value. This value right here is 8.6. That's the height. This value right here, I don't see a number there. But if I look for parallel sides, I know this is going to be a 12. So I'm going to take 8.6, 12 times 8.6 divided by 2. And when I multiply that out, 12 times 8.6 divided by 2, I get 51.6 yards square. Now, please don't stop there, because what you found right now is the base area, and you have to finish this problem by multiplying that value by the height. So I need to go back to my shape here and ask myself, okay, looking at that triangle, along which other side would I have to stretch this to make it three-dimensional? Well, the 10 is an element of the triangle. It's a side of the triangle. That's not going to work. So if I color in my triangle here, I need to ask myself, which side would I stretch it along? And the answer to that is that 7. I'm going to stretch it up the 7. So my volume is going to be base area times height, 51.6 times 7. Multiplying 51.6 times 7, I get 361.2 yards cubed. So as you're working through the worksheet, please be careful. Make sure that you correctly find the area of the base. When it is a triangular prism, the base will be a triangle. Think about the name. Please make sure you remember to divide the base area by 2. Again, a triangle, base times height divided by 2. And make sure you are selecting the correct height to stretch that base along to make it three-dimensional. If you get all of them right except one, or all of them correct, you have mastered the volume of triangular prisms and you can move on. Good luck.